Hello everyone and welcome back. In this lecture we'll continue our discussion on logistic regression. Let's start by looking at our data set. So I'll call the head method. So we have 4 columns, right? Admittance, GRE, GPA and rank. What we'll do is we'll try to predict admittance based on these 3 features: GRE, GPA and rank. So if you consider rank, for instance, if you take the first row, the rank is 3. If you take the second row, rank is 3. Third row, rank is 1. We saw that the values for rank are either 1, 2, 3, 4. But this doesn't mean much for our logic, right? So what we'll need to do is convert these ranks into a 0 or 1 value. For instance, the first one, the rank for this first student is 3. So what we'll need to do is create a dummy variable for rank. So that dummy variable will have the values rank 1, rank 2, rank 3, and rank 4. So we'll create these dummy variables, and for the first row, the school's rank is 3. So rank 1, 2, and 4 will have the values 0, whereas rank 3 will have the value 1. And if you take this fifth row index 4, the school's rank is 4, right? So for that one, the first 3 ranks, rank 1, 2, and 3, will have the values 0, and rank 4 will have the value 1. That's more beneficial for our dataset to build our logistic regression. Otherwise, this just rank 1 through 4 doesn't mean much. So we'll create a dummy variable, and instead of rank, we'll have this rank 1 through 4. Let's start to do that, and we'll use a method known as getDummies. So pandas has a method known as getDummies. So let's do that. pd.get_dummies, and then we'll pass our rank column. So let's index it, data, and then rank, and then we can pass the prefix attribute and then pass whatever prefix you want. I'll just pass rank, so that when we create our dummy variables, it will have rank _1, rank _2, and so on. Okay, and let's save this in a variable called, let's say, dummy ranks. Okay, now let's try to see our dummy ranks, dummy variables, by calling the head method. Let's run it. So we have, for the first row here, rank is 3, right? So rank 3 column here has the value 1. So we have created 4 dummy variables for our rank. Rank 1, 2, 3, 4. So wherever the value appears, we'll have 1. And if it doesn't appear, it will be 0. So if we call the tail method on our data set to show you the last 5 values, and let's call again the tail method on our dummy rank variable that we created here, dummy ranks.tail, run it. So here, the very last row, rank is 3. So the rank 3 column will have the value 1. Okay, so that's the importance of dummy variables. Okay, now that we have our dummy variables, there is a condition known as multi-collinearity. What that means is, when you introduce dummy variables in your dataset, one dummy variable can influence another dummy variable. There might be some interdependence among the dummy variables, and that condition is called multi-collinearity. And one method to avoid this multi-collinearity is to exclude. Usually you exclude your first dummy variable. In our case, we'll exclude rank 1, and that will prevent this multicollinearity. And if you want to read and know more about multicollinearity, you can find more about it on Wikipedia. It's a phenomenon in which two or more predictor variables are highly correlated. You see, meaning one can be predicted from the others. So we don't want multicollinearity. That's why we'll drop the first column here, rank 1. Okay, that's what we'll do next. Okay, right now we have our dummy ranks, and then we have our other two features that we need, GRE and GPA. What we'll do is we'll use the data frame method and then merge or join this GRE and GPA with our dummy ranks. Okay, so let me create another variable. I'll just call it columns we need, and then I'll save we need admittance, which will be our target, GRE, and then GPA. So we'll need this from our original data set, right? And we'll merge it with our dummy ranks data frame. Okay, for that we'll use the join method. So we have from our original data set, we'll index our columns that we need, which are admittance, GRE, and GPA. Then we simply call the join method, and then we want to join it with our dummy ranks dataset, right? Our dummy ranks data frame here. But we said we will be dropping our rank 1 column, so we'll only index ranks 2, 3, and 4. So we can call the ix method on it, dummy ranks.ix, and we want to get all the rows, and for columns we only want columns rank 2, 3, and 4. So we have rank 2 and then colon, meaning rank 2 and everything after that, rank 2, 3, 4. Okay, so that's the join method, and we can save this. I'll just save it in the same variable data. You can save it anywhere else in a different variable if you want, but I'll just save it in data. Okay, columns we need. Okay, we haven't run this cell. Let's run it again. Now let's run this. Okay, now if we call our data, we'll find the merged data set. We have admittance, GRE, and GPA from our original data set, and then we have the columns rank 2, 3, and 4 from our dummy ranks data set. Now we have a good data frame or data set to work with, and we are ready to build our logistic regression model. So what we'll do next is we'll split our data set into training and then testing data sets, and then we'll use the training data set to train our logistic regression model, and then we'll predict using the testing data set. And that's what we'll do in the next lecture. Thank you everyone, and see you at the next lecture.